Okay, so we want to pick back up today with the finance discussion and with math. Shocker, right? Remember, these chapters are very math heavy. Turn in your book, page 449, and I know I'm jumping ahead here somewhat, but turn in your book to page 449. We want to talk about something called a loan factor, and we're going to be working on that same worksheet that you guys had last week, or not last week, on Tuesday. We had done up through number 14. But number 15 says, using the loan factor chart in your text, please identify the correct monthly principal and interest payment for each $1,000 borrowed on a 15-year note at 5.5% interest. So let's talk about a loan factor. In your textbook on page 449 is an important chart. So your homework for the weekend is going to be to memorize that chart. I don't know why you're laughing. I'm kidding. So, loan factors. I struggle with why we still teach them sometimes. This is it's not antiquated in the sense that it's not used. It's antiquated in the sense that it's not necessary any longer to have loan factors. So this is a remnant of when I got in the business before everybody had one of these in their pocket. When you didn't have smartphones, you needed to be able to sort of on the fly calculate how much somebody's mortgage payment would be. Well, why has this sort of taken away that need? Because now you can calculate exactly what somebody's mortgage payment would be because you can load up a mortgage calculator. You can have an app on your phone that's a mortgage calculator. But loan factors predate that. When I got into the business, I used to have, and the lenders would all the bank would give it to you because they branded it. And it was like a little sliding chart. You take it out, and it had a window on the left side, and you would turn the wheel to get to the correct interest rate for whatever interest rates happened to be at that point in time. And then it had a slide up at the top, and you would slide it, whether it was a 15-year loan or a 20-year loan or a 25-year loan, and you get to the correct loan, and then there'd be a little red window in the middle of the thing, and there was one number that it would show you. That one number is something called a loan factor. So here's what a loan factor is. A loan factor is the amount of the monthly payment for just principal and interest. We're not talking about taxes and insurance because obviously that changes. But it's the principal and interest payment for every $1,000 you borrow. So if you borrowed $2,000, what would you do with that number? You would double it, right? Because it's a payment for every $1,000 borrowed. So look at that chart in your book on page 449. And we'll just go right at the top. Look at the 4% interest rate. So at a 4% interest rate, if you take out a 30-year mortgage, so does everybody see where I'm looking? So it's the very top line all the way on the right-hand column. Does everybody see that? Okay, 4% interest rate on a 30-year mortgage. See it says 4.78? Well, that's actually dollars and cents. It's $4.78. So if I borrowed $1,000 at 4% interest and scheduled to pay it back over the course of how many years? 30 years. Then what would my monthly payment be? $4.78. So if I borrow $2,000, what do I do with that number? Multiply by 2. If I borrow $5,000, what would I do with that number? Multiply by 5. If I borrowed $50,000, what would I do with that number? Multiply by 50. If I borrowed $250,000, what would I do with that number? Multiply by 250. It is a payment for every $1,000 I borrow. So all I need to do is find the loan factor and then multiply times the number of thousands. Now, what I've always told my students as far as the math of it, it's sort of a trick with the math of it, was we'll just work with that 478 loan factor. So once we found in the chart that the loan factor is $4.78, if I have a $250,000 mortgage, I'm just going to multiply times 250. The way I tell people to remember that is write down the mortgage amount, $250,000, and take the comma and turn it into a decimal. That's the way to remember number of thousands, right? So just turn the comma into a decimal, and that's the number you multiply by. So if I had a loan of, for example, if I had a loan of $175,000, $175,000 mortgage loan, what number am I going to be multiplying that loan factor by? 175. So now all I need to do is find the correct loan factor in the chart. Does that make sense for everybody? So look at that worksheet again. That number 15. It says, using the loan factor chart in your textbook, please identify the correct monthly principal and interest payment for each $1,000 borrowed on a 15-year note at 5.5% interest. Take just a second and write that down. I'm going to walk around and look. So it wants you to identify the loan factor, so the PI payment, for every $1,000 borrowed on a 15-year note at 5.5% interest. So I want you to write down the correct loan factor. Where do you get that from? Okay. Good. One of those weird people that does your eights is like disconnected circles. Good. 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 Shut up. Yes. Good. 8.18. Yeah. 8.18. Good. Everybody's got $8.18, correct? $8.18. That is the correct loan factor. So now you're halfway done. You know how to read the chart. That's the biggest part. So what we mean is that for every $1,000 we borrow, our monthly payment is going to be $8.18. So here's why that's still useful. Yes, it's an antiquated idea, but you want to look smart to your client. On the fly, you can tell them how much their monthly payment would be, especially when they start comparing houses. If you're out shopping for houses and they're looking at one that's $200,000 and another one that's $210,000, would it be impressive to them that you could say, well, that's about $80 more a month, just instantly? And the reason I know that is because I'm borrowing an extra how much money? $10,000, right? So 200 versus 210, I'm borrowing an extra $10,000, and their loan factor is what? $8.18. So that's 10 times $8 basically, right? So it's an extra $80 a month. Would that be impressive to a client that I could just off the top of my head say, oh, by the way, your payment's about $80 more a month on that house versus this house? That's where it is still useful. So you can make that sort of on-the-fly comparison. All right, so go ahead and work on number 16 then. Calculate the monthly PI payment for a $50,000 30-year fixed-rate mortgage at 6.5% interest. So take just a second and work on that. All right, so what's going to be step one on that? Finding the loan factor, correct?
Right.
And what do they tell us about the loan?
30-year.
It's a 30-year fixed rate, so we know we're dealing in the far right column. And at what interest rate? 6.5, 6.5%. So when I look at the loan factor chart, I come up with $6.32 as my loan factor. Does that number sound familiar for everybody? So we got $6.32. And now we just need to know what to multiply that by. What did they tell us about our loan amount? How much?
$50,000.
It's a $50,000 loan, and so what I said I like to do is just turn the comma into a decimal. So what are we multiplying by?
50.
So times 50. And when we do that, 632 times 50 equals $316 per month in principal and interest payment. Does that make sense for everybody? Could I add a wrinkle to that question now and ask you what the balance would be on that loan after the first monthly payment? Do you have all the information you would need to be able to calculate the balance on that loan after one payment? Why don't you do that? Go ahead and calculate the balance. Remember, that's where we use the, you use the chart to make your own or use mine, but get to the point where you can make your own for sure. I'm sorry? No insurance and taxes, right. This is just PI. Right? They didn't give you a PI-TI payment, they just gave you PI. So we want to calculate what the balance would be on that loan after we make one payment, first monthly payment. Ready? I come up with $49,954.83 after that first payment. So when we start breaking that down, remember we started with a $50,000 balance. So you put that on line 1 and you just come down to the next line, right? And how many payments did they ask us to run? Just one, so that's all I'm going to write in. So it's kind of a reminder of myself how far I need to go. If they'd asked me for 2, I'd go ahead and write in 316 twice on 2 lines. But since they only asked me for 1, I wrote it in 1 time. And then I started breaking that payment down. In order to figure out how much of that payment went toward principal, I had to first calculate what? Because what do we pay first? We pay the interest first. So I calculate the interest first, and that's where I took that $50,000 and multiplied it times the 6.5% rate, and that gave me annual interest of $32.50, right? But I don't want annual. This is what kind of payment here. These are monthly payments I'm dealing with, so I divided that by 12 to get $270.83 in monthly interest. And that's the number that I carried up into. I took that number straight from here into my chart, right? And once I had filled that number in, couldn't I just simply take the 316 minus the 270.83 to get that there was $45.17 left over to go toward my principal, right? Remember, think of that payment as a bucket of money. You pay the interest first, and then you pay any insurance and taxes. In this case, there were no insurance and taxes to come out, right? So what we're left with is just the amount that's going toward the principal, which is $45.17. And then I simply took that number and applied it back toward my balance, which left me with my new balance of $49,954.83. How do we feel about that? Everybody feeling okay? All right. Good. If that's something that's stumping you, then just practice it, right? Could you just take the same one and go 3, 4 more payments until you get the hang of what you're doing? And you don't need me to make up more questions like this for you. You can just take the same questions and add another payment or 2 on there and just keep running them until you're comfortable with that process. It's just repetition. Okay? All right, so let's look at the next question on our little worksheet there again. It says calculate the monthly PI payment on an 80% loan-to-value loan used to purchase a $360,000 home in Raleigh if the borrower elected for a 30-year fixed rate note at 5.25% interest. So this one's not much different than the last one, except what did they not give us in this question they did give us in the previous question? The loan amount. In the previous question, they just said the loan amount is $50,000. In this one, they gave us a purchase price and a loan-to-value ratio. So I would say the first thing we need to do is calculate the loan amount. Do you agree with that?
Yes.
So things to calculate the loan amount. I need a purchase price, I need a loan-to-value ratio. Well, they told me it's a $360,000 purchase and an 80% loan-to-value ratio. So sometimes 80% LTV, which remember, that's just the percentage of the sales price that's being borrowed, right? Okay? So $360,000 times 80% loan-to-value gives me a loan amount of $288,000 for my loan. And I know that ultimately, if I'm calculating the payment, I'm going to be changing that comma into a decimal, right? Because the number I'm going to be multiplying by is what? 288. Is everybody with me on that? So 288 times what? Well, what do we know about the loan?
30 years.
It's a 30-year at 5.25, 5 1/4. So I'm going to find the 5 1/4 line. Follow it all the way across, $5.53. Does that look right for everybody? $5.53. So times 5.53. So 288 times $5.53 equals, I come up with a monthly PI payment of $1,592.64. So that's their monthly house payment, not accounting for taxes and insurance. So if we wanted to figure out their total monthly house payment, we would need to know what the annual taxes and insurance were and then divide them by what? Divide them by 12 and add that number back in to get our total monthly PITI payment. But for just principal and interest, it's $1,592.64. Go ahead.
Would this be on the test?
I told you you had to memorize the chart. Yes, they'll give you the chart. They give you the chart. They give you, usually it's actually easier than what we're doing here because they give you like a snippet of the chart. They give you like 3 lines of it, basically, or 4 lines. They don't, they don't give you the whole full page. Or sometimes they'll just say the loan factor is this, or the payment per 1,000, because payment per 1,000 is a loan factor. We all feel okay about this? I think this is pretty straightforward math for most of you, once you understand what a principal interest payment is. The big thing is understanding what a principal interest payment is. Alright, so back on the worksheet, look at the next question. This is an interesting one that people consistently get wrong on the test, even though the math is not that hard, because you actually make this question harder than it is. Calculate, or what is the interest paid over the life of a $100,000 30-year fixed rate 4.5% mortgage with monthly principal and interest payments of $506. So first of all, what are they asking us for here?
The interest paid over.
Total interest. They just want the interest part. They don't care about the principal, correct? They just want the interest. Let me tell you something you don't need in order to answer this question. You don't need the interest rate. If you're starting to do math and multiplying by some percentage, you've gone way too far, too hard in the wrong direction. It's not that hard. Because the truth is, you can't get there with the interest rate. The interest rate would only give you annual interest in the first year. But what is that interest doing over time? It's decreasing. So you can't calculate how much interest they would pay in year 1 and then multiply that times 30 years. Because it would be way too much. Because every year the interest is doing what? Is going down. The problem is I also can't, so somebody said, well, I could calculate how much interest I paid in the first payment and then calculate how much interest I paid in the second payment. Sure you could. Yes, you can do it that way. For 360 payments, you could do it that way. That would take a little bit of time, I would think, right? There's actually a much more straightforward way to handle this. They gave us the monthly payment, right? Do we know how many times we're going to pay that payment per year? 12 times a year. For how many years? 30 years. So couldn't we just simply say, well, I'm paying $506 a month for principal and interest times 12 months a year times how many years? 30 years. So in total, I'm going to pay $182,160 for principal and interest over the life of that loan. Does everybody agree with that?
Yes.
Grand total, if I make every single payment, I'm going to pay $182,160. That's not what they asked me for, though. They asked me for what? Just the interest. What I just calculated is the principal and the interest. How can I get rid of that piece? I could subtract out the principal, and how much was that? $100,000 is the amount I borrowed. So the amount of interest paid over the life of that loan is $82,160 in interest. Is that simpler than calculating the interest payment by payment?
Yes.
It's a lot better. It's even simpler really than doing it the way you kind of, I think a lot of times we want to just go take the interest rate and then figure out the annual interest and multiply by, it's even simpler than that really, because all you need to know is that monthly payment. If you know the monthly payment, and what's the best way to figure out the monthly payment if they didn't give it to you? If you know the interest rate and you know the term, can you get to the monthly payment? Because you can do a loan factor, right? See how it starts to all tie back in together? If you know the loan factor, you can get to the monthly payment. Alright? So, $82,000 over the life of that loan in interest. Number 19 says, what would be the interest paid over the life of the same loan in question 16 if the borrower elected for a 15-year term at 4% interest with monthly PI payments of $739? So, we're going to do the same thing here. What number do we need? 739. So we need to know $739 a month in principal and interest times how many months a year? 12 times how many years? 15 in this case. So 739 times 12 times 15, I get $133,020 in principal and interest, but they want to know what? Just the interest, so I'm going to subtract out the original principal, which is the same $100,000. Is that a significant savings in interest?
Yes.
In this case, we're only paying $33,020 in interest versus, if you look back at the last one, $82,000 in interest. So $33,020 in interest paid over the life of that loan. Is that, everybody okay there? Feel pretty good with that? Or was it, did I look at the wrong question? Oh, sorry. Sorry, well, you can tell me that. You can tell me I messed up. Sorry, I was just assuming it's question 4, so I did the wrong one. Let's do number 16 then. Alright. So it was only $50,000, right? Okay. Alright, so let me erase that.
Oh, yeah, 16.
Everybody see what Lynn's talking about? I looked at the wrong question. Alright. So the principal in number 16 was what? $50,000? In principal. So that leaves me with $83,020 in interest. When I compare it to number 16, which is what the question says. All right. Thank you, Lynn. And then number 20. What's the difference? You know what it is? I think a question's got added in here. So on number 20, where it says in questions 16 and 17, something refers back. I think we were meant to do it. Something got screwy there. So let me look at it real quick and tell you what it should say. Because at 4% interest on a 15-year term, 15 is 740. Yeah, it's 100. So it should have been the $100,000 one. It should say, rather than question 16, it should say question 18 there. So change that on your question 19. It should be the one in question 18. All right. It should be the 30, and we'll go back and fix that. But just update on your sheet. That should say question 18. Okay? Fix the sheet, and then we'll go back and do the math. And then on number 20, it should say questions 18 and 19. Those are the two that we want to compare. I think somehow questions got combined in 2 different worksheets, and they didn't get updated correctly. So let's look at number 19 again. It says, what would be the interest paid over the life of the same loan in question 18? So nothing changes here except that principal amount, because the principal amount in question 18 was what? $100,000. All right. So we put that $100,000 back in there. Then this number changes to 33, right?
Yes.
All right. So now the next question. Since we've updated, did everybody fix that? I don't want you to have it wrong and go back and not what you're looking at. Not know what you're looking at. Everybody fix that on your worksheet? Okay? So the next question said, what is the difference in the interest paid over the life of the 2 loans in questions 18 and 19? So if we go back and look at the interest paid over the life of the 2 loans, here's number 18. It was $82,160, right? So I'm going to write that number down. $82,160 was number 18, right? What was number 19?
33,020. Oh, 020.
33,020. And it wants to know the difference between those two. So what could I do? Subtract them out. So if I take 82,160 and subtract 33,020, I end up with a difference of $49,140. So what we've done here is compared how much interest somebody would pay on the same purchase with two different loans, right? What was the loan in question number 18? It was a 30-year at what interest rate?
4.5.
4.5. And then in question 19, it was a 15-year at 4%. And so that's a pretty good real-world comparison, folks, because that might be what somebody's looking at. If they go to a 30-year, they might see that rate be at 4.5, or if they drop it to 15, the rate would drop to 4. One of the incentives to do shorter terms is you usually get a little bit better interest rate on a 15-year note. It has a dramatic effect, right? If you look at it, you drop it from a 30-year to a 15, and then change the interest rate a little bit. We saved well over half of the interest charges on that loan. Almost 2/3, really, of the interest was saved. Everybody okay? I'm calculating that difference there. All right. So work on number 21. Go ahead and do number 21. How much interest paid over the life of an 80% loan-to-value loan used to purchase a $240,000 home if the borrower opts for a 15-year fixed-rate note at 6% interest? So you guys go ahead and work on that. There you go. Calculator guy. So there's your loan amount, and that's your loan factor, right? Okay, so go ahead and do that.
That's your monthly PI payment, right? Okay. Agree with that? Okay. That's your monthly PI payment. There you go. Perfect. Don't need that interest rate. Well, you look the payment up, it's right here, right? You need to know that. Get rid of that. So here's your loan amount. To calculate your payment, you take the loan factor. This is the loan factor, $8.44 times 192, because that's the number of thousand you're borrowing. Right, so this is 92. Got it. I think it's 44, right? 44, not 66. Are those fours? Yes. Okay, all right. As long as you know there are four. Looks like a 6 to me. Yes, as long as you know it's a 4.
I did that, but it just looked wrong.
That's the total principal and interest you pay for the whole life of the loan. So it's gonna be a big
Principal
number.
and interest,
It's
right.
principal and interest,
Okay,
right?
that's what caught
Because
me.
remember, this is a PI payment.
Right,
okay?
exactly, right.
Yep. So that's your total principal and interest.
What I'm trying to find just the interest.
Right, so you're taking the loan amount out. This is the loan amount, so you subtract out the amount you borrowed. That is right. Yep. Good. Yeah, track that.
When I saw that 291, like I flipped that.
Okay, rid of that.
I'm in trouble.
So this is your PI payment for every month, right? How many months a year you pay it? And how many years? So that is. No, no, okay, this one. So that's your monthly PI payment. All right, PI. Okay. Anytime you have that payment. For 2 years. Annual PI payment.
All right, so let's take a look here. Most of you got your loan amount right away. You recognize you had to calculate your loan amount, which is absolutely the first step here. So we got $192,000 being borrowed, right? Because it's finance. We don't care about the purchase price, we care about the amount borrowed. So the $192,000 loan. Once you got to that, the purchase price should disappear in your mind. Because at this point, everything is based on the loan amount from that point forward, correct?
Right.
So we got the $192,000 loan. Most of you correctly looked up the loan factor. I saw everybody had $8.44 written down. Remember, that's the payment for every $1,000 you borrowed. And what I saw was most of you correctly multiplied that times the 192. I think almost everybody, if not everybody, had 16, 20, 48 written down. Now I think some of you didn't know what to do at that point. Okay? remember what that 16/20/48 is. What is that? That's their monthly, what? Principal and interest house payment. That's what they're paying the bank every single month in principal and interest. So now let's ask the question, what are they asking me for here? They want to know how much interest I'm going to pay over the next 15 years if I make that payment every single month, right? So what I need to do is make that payment every single month for the next 15 years. So times 12 times 15. And what that totals up to is this $291,686.40. That is your total principal and interest payment over the full life of the loan. So if I make every single payment on time, I'm going to pay $291,686.40. But not all of that is interest, because some of it is money I actually borrowed, right? So to get to the interest, what do we need to do? Subtract out the amount that I borrowed, the loan amount. So I subtract out the $192,000, and that leaves me with $99,686.40 in interest paid over the life of that loan. Where'd you get snagged?
At the very end.
At the end. So what'd you do?
I used 240 instead of.
You subtracted the purchase price, right? Okay? That is a very common sort of snag. Once we get to the finance part, we start to deal, we know at the beginning we have to calculate the loan amount, but then at the end we forget it's the loan amount that matters, not the purchase price, right? So one of the things I do, kind of remind myself, is when I do that $192,000 loan, I'm like reminded I'm never going back to that 240 number, because that 240 number doesn't matter for me, because I'm only dealing with the loan from this point forward. Okay? How we feel about that, because that puts together a lot. That is an example of a test math question right there. That is kind of putting all the pieces together that you might see in a math question from the finance section on the test, because you had to know how to use a loan factor, you had to know how to do a loan to value ratio, and you had to understand how to calculate interest paid over the life of a loan. It's kind of like 3 topics all rolled into one ugly little package, right? That's a good example of a math question from the exam. So we need to get you to the point where you feel comfortable with that, if you're not already. And it's okay if you're not already. That's why we do it. Number 22, how much additional interest would be paid? I have to ask a question. Did I leave my Surface pen somewhere out there on somebody's desk? Oh, there it is. Thank you. How much additional interest will be paid by the same borrower in question 19? So fix that. That's going to be question 21. That's what happened. I think I added a couple questions here and I forgot to go back and change these references. So question 21. Question 22 should read in question 21 because it's the one before it. So how much additional interest will be paid by the same borrower in question 21 over the life of their loan if they opt for a 30-year note at the same interest rate? So we want to keep the same rate, which they told us was what? 6% interest, but we're just going to a 30-year note. So the loan amount is going to stay the same, correct? So we're starting with the same loan amount, which was $192,000. But now we're going to have a different loan factor. Yes, 6% for 30 years looks like $6 even to me. Does that sound right for everybody? So we're going to take 192 times 6 to get our monthly PI payment. And that equals $11.52 per month. I just want to pause you for a second and look at a comparison. This right here is a case for why people do 30-year notes versus 15-year notes. Look at the difference in the monthly payment. For a 15-year note, it's $1,620.48. Same loan at 30 years is $1,152. So it's a $500 a month difference. That's a substantial difference. You're going to pay for it with interest, though. You're about to see the magic of that number for the banks. All right? So we're paying that 12 times a year, but now we're paying it for what? 30 years. So when we do 1152 times 12 times 30, we get a whopping $414,720 in principal and interest. We're going to do the same thing we did previously. We want to subtract out the loan amount, right? 414,720 PI minus the original principal amount of 192. I get now $222,720 in interest paid over the life of that loan. Does everybody agree with that? But now that's not what they asked me for. They didn't ask me for the interest paid over the life of it. They asked me for what? They want to know how much additional or the difference paid between the two. So now what I need to do is go back and look at how much interest I paid in the previous one, which was at $99,686.40, right? What do you think I'm going to do?
Subtract.
$99,686.40. And that is an additional $123,033.60 in interest to go from a 15-year note to a 30-year note on the exact same borrowed amount. Exact same interest rate. It's an additional 120. Notice it's not double the interest, right? It's substantially more than double the interest. It went from $99,000 to $222,000 in interest. At that point, we're paying more interest than we are principal. If you look at it that way, a 30-year fixed rate, 6% note, you're actually going to pay more in interest than you will in principal. And those numbers get substantially uglier as you go up in interest rates. I mean, I'm not saying that some people in the room are old or anything, but there's probably some people in the room that had like 17% interest rates. What was your first interest rate?
Interest rate was 7.25.
7.2, that was the first one? Okay, that's not too bad. That's not too terrible then. If you had done it in the late 70s, it would have been more like 13.
Well, that was veterans too.
Right, there's a VA loan. Okay?
So,
1972.
No, I was not born then. I'm not that old. That was when the world was still black and white. Yes.
So within 30 years, that house will value that price. Plus, like, can you sell the house for like, let's see, 400 something in 30 years?
Probably not. Most likely not. And Lynn's question was, am I likely going to be able to sell that home in 30 years for as much as I've paid in? Probably. Well, maybe in 30 years. You might see it double in value in 30 years in a reasonable market. So maybe. But again, you can't really look at it that way because for most people, this is not a question of money in, money out. It's a question of I can afford to do it if I finance versus I cannot. So you have to think of the alternative. If they're not buying this house, what are they doing?
Renting.
Renting. And here's the truth of the matter. Are you still paying that interest if you're renting?
Yeah.
Yeah, you're just paying it on somebody else's note. The biggest myth in the home world is, well, you know, I don't pay interest because I rent. Yes, you do. You just pay somebody else's. Because you can believe that that's factored into the cost of the rent. Okay? How do we feel about that? And actually, one of the biggest advantages of home purchasing is what we call a hedge against inflation. Even though that number is pretty ugly, I know that 20 years from now, how much is my house going to cost me a month? $1,152. Is rent going to do that over the course of 20 years?
No.
Absolutely not. So that's one of the biggest advantages of purchasing, even if you do finance, is just you're locking in the cost of this thing over a very long period of time. I mean, you know, right now I've lived in my house for the last 9 years for the exact same amount every single month. And if I stay there another 50 years, I'll know that for 21 of it, it'll be that exact same amount every month. And then after that, it'll be much, much cheaper because I'll only be paying taxes and insurance. So, you know, just that idea of blocking you against the increases in price that you would see in the rental market is a big deal. That is, of course, assuming you don't refinance all the time. Of course, if you refinance, then your payments are going to change. Especially if you do like cash out refinances, where you're taking cash out of property. How we feel about these? Can we do these maths? Good? Good. Good. What else do we have on this thing here? That's it. That's it. So let's do this. Let's take a break then, and we'll come back and go through the rest of the lecture for chapter 14 and chapter 15 and 14. 14 and 15. Yeah, we need to finish 14 first.